Good afternoon, everyone, and welcome to the Billigence webinar. My name is Brandon Mercer, and today I'll be running this session on analyzing JSON files in Snowflake and Alteryx. I'll begin by giving a bit of an overview of who Billigence are and what we do, and then we'll dive straight into the content. So what I'll do to begin with is I will share my screen like so, and we'll get straight into it. So as you can see here, Billigence are an international consulting company that combine technology, tools, and resources to provide data-driven insights to organizations, which can help strategically position them in better state. This is what we do at Billigence. Our 5 key pillars. We work in cloud data architectures, data governance, predictive modeling, data visualization, and automated CRM systems. Today, looking at Snowflake and Alteryx, we will dive into the cloud data architectures section, as well as kind of jump across pillars. If you're familiar with Alteryx, you know it sort of sits as a one-size-fits-all program. So we will be jumping between these pillars today to give you some insight into how we can analyze JSON files. As a final statement on Billigence, here is a list of our clients. As you can see, there are some quite high-level finance and retail clients, as well as a strong presence in government and higher education. We'll jump straight into the content now about parsing JSON files. So we'll look at, in order, we'll look at Snowflake, Alteryx, combining the tools, and then I'll wrap it up with the ongoing schema-on-read versus schema-on-write discussion, which sort of ties in throughout the whole webinar. So I'll kind of just wrap up the final points when comparing the two tools. I guess the first step is, what are JSON files? JSON files are a semi-structured data type that stands for JavaScript Object Notation. Now, within JSON files, you'll find object and arrays, and then objects within objects and arrays within arrays, which are known as nested files. This is the example we'll be using today. As you can see here, it's quite simple, but complex at the same time. Now, I just wanted to use this example to show how, I guess, scalable Snowflake can be and how forgiving the two softwares can be when looking at semi-structured data. We have the parent here, Johnny. Within Johnny, there's a nested object. So the whole file sits within an object, and then the nested object within phone number. Within children, we see objects within an array here, and within cities lived, we see nested arrays. So there's a starting array here, a finishing array here, and then concatenated years lived in here. So this is kind of an example that has, I guess, 3 different structures of JSON within the file. A lot of people would probably be a little bit cautious to attempt something like this traditionally because of the, I guess, difficulty of working with semi-structured data, and then on top of that, the 3 different types of semi-structured data that we have within this JSON file. So that's why I chose this example. So what I'll do is I'll open my Snowflake web UI, and I will also put my JSON script here, just so you can follow along. So what I've done within Snowflake as a preparation here, I've created a database called My Webinar. Within this database, I've created a table called JSON Webinar. Now, this table has a single column, which I've named column 1, with the data type of variant. Now, this is an extremely important point. Snowflake has a file format known as variant, which it uses to ingest semi-structured data. So you can ingest JSON, awk, Parquet, XML, and Avro into Snowflake with ease. So what I've done, I've created the JSON file format and ingested this file into Snowflake under our My Webinar table. So in a worksheet here, we can simply use our My Webinar database that I have created and then select all from our JSON webinar table. As you can see, it loads it into our single field, which what we defined as column 1, which loads our JSON file like so into Snowflake. Jumping straight into querying, if you're not familiar with Snowflake, it uses ANSI SQL. So it is quite adaptable as a cloud warehousing system. Most data engineers and people who work with data are familiar with anti-SQL, as it is the most common. So we'll begin with some simple queries. What you can do is you can simply select one, and we'll take the full name as our starting point up here. And from Json_webinar, which is our table, and we can run this query. Now what we'll get here is Snowflake's been able to recognize that from the full name, this is our field after this semicolon here, Johnny Appleseed. As you can see, it does come with the speech marks attached. So what we can do is we can cast it as a string. So within Snowflake, the cast function is actually implemented as a double colon here. So we can simply double colon string and rerun that file, and we will get our Johnny Appleseed without speech marks. We can start to expand on this nice and quickly. So again, simply selecting from our only column, we might want to take the age as an integer. And we also may want to take the gender as a string. Again, like with any SQL, you can name the column with an as and rerun this query. Now we have our Johnny Appleseed 42 and our male. Obviously, we can go back through if we wanted to and rename the columns accordingly, which I will do for age, just to show you how easy it is. Now, this way, obviously is nice and simple because it takes the very first part of the JSON. There's no nested arrays or nested objects or anything like that. Really, really simple here. So what I'll do is I'll look at the object within the object here. If we selected column 1 phone number, we need to specify which indent here we'd like to take. So what we can do is we can select one phone number. Be aware of case sensitive functions within Snowflake. And then to get our object within an object, it's quite simple. It's just a full stop, and then we can specify, okay, we want to take the area code. Again, we might want to format this as a string, as area_code from Json_webinar. We run this this query, as you can see, we get our area code of 415. Really, really easy to start querying some of this JSON data, particularly when you're looking at big files. And there's a lot of nested arrays, multiple indents. As you can see, it's quite simple to start querying this sort of data. Now what we can do is start to look at the children section of the JSON file where things sort of sit within objects. So the first child, name Jaden, gender male, age 10, clearly a different structure to the above here when everything's on a separate line. So it's a little bit different when you're looking at an example like this. We can select column 1 children. Now we want to specify what child we're looking at. So that's quite easy. It's just a position metric where you use the square brackets. Like most SQL, it starts at 0. So this will be child 0, child 1, and child 2. Once we do this, we can specify what part we want to see, similar to the above where we use the full stop. So we might want to see name, for example, of child 0. So we grab the name for webinar, and we can run that query accordingly. We get Jaden. Again, if you wanted to format it as a string to remove the speech marks, there you have it. So it's really nice and simple. We're looking at the only column we have, specifying which, I guess, object, children, and then within the child, we want to look at the first one and the name. So it's really quite interesting how Snowflake does this. But if we wanted to, I guess, expand on this and start to build maybe a children's table, we need to use the flatten function. Now, the flatten function explodes values into multiple rows, which is what we want in this instance. It takes a variant column, which we have identified as one we have created, the JSON variant column, and produces it in a lateral view. Now, this is really crucial for semi-structured data because it allows us to turn it into, I guess, more of a traditional relational representation. I'll show you a really simple example where we can select, put our placeholder, and have a value. Now, within the value, we want to take the name. Again, as a string, as child name. This placeholder F is what we will refer to as our table lateral flatten, which you'll see down closer in the from clause. Again, we want to take our placeholder. Which value do we want to see? We want to see gender, which I'm just getting from here. So name, gender, and age. Gender, student. And finally, we will take our value of age. Again, we'll format it as a string. Like before, it's simply from JSON_webinar. But now this is where we specify our flatten function, which is proof as part of the query. So we grab our table and we flatten it. This explodes the code into, this explodes variant functions into, I guess, relational representation. So what do we want to flatten within the table? We want to flatten our only column, which is column 1, and we want to flatten the children portion of that column. We can place our placeholder, which was F, and we can run this query. Now, as you can see here, we have our child name, our gender, and our age in a really traditional child table here. We've taken really semi-structured flat data here, and we've exploded it within a few lines of code to a proper relational database structure. Again, just quickly running through the code, the F is the flatten function that we specified here, and the value just specifies which part we want to take. Really simple, really useful query. Now, what Snowflake has the ability to do within this, I guess, variant function, if another element is added to the array, so say a fourth child, we won't have to change the SQL. Flatten allows us to, I guess, determine the structure and of the content in the array on the fly, which is really important. So it makes it resilient to change in the JSON document. So if we get more and more added children with different parts and different, I guess, structures like so, it allows us to keep the code from running errors. It will adapt accordingly, which we'll see. Now, what we can do if we get, say, an array within an array, which sits in the cities lived example. So we've looked at a normal JSON object with nested objects. We've looked at a JSON array with objects in the array. And now we'll look at a JSON array with an object and a nested array. So it's getting quite complex here. But again, we can produce, I guess, the cities lived table, which again, with the variant function is resistant to any change and adapts accordingly, which is really cool. So what I'll do, I'll take the full name as a string as the header name. You'll notice this is the code we used before. So I'm simply just grabbing from column 1 the full name as a string. Now what I'm going to do, I'm going to use 2 more placeholders because we're going to have to flatten this table twice. So I will use the cities lived placeholder as CL. Take a value. Now, which value do I want here? I want the city names. So I can grab the city name like we have previously. with a semicolon and then the string city underscore name. This is similar to what we've done up here. Again, we will do a years lived value. We need a placeholder because we'll be flattening this as well. So we can take the YL for years lived dot value as an. We don't have to specify what particular part of years lived within cities lived because we have a nested array in here. And we'll simply name that years lived. On the JSON webinar table, nice and simple. And this is where we need to flatten our table twice. So we will flatten the column 1 city lived section of the code, which obviously will flatten each object within the code. So we'll flatten this and this and this and this. But as we specified, we also need to deal with the years lived in within that flatten section. So CL there. Now that, again, just to quickly specify, that will flatten the cities lived into 4 different sections. Within those 4 sections, we want to flatten the years lived. So now we need to take our flattened files from CL lived, so not the column 1 anymore, but rather from the cities lived. Our previous line just here. Take that value, apply it to our years lived, and I will run this table. Now, as you can see here, this provides us with, I guess, a relational sort of structure. We've got our parent name, our city name, and where he's lived. So in London, he's lived in 4 different time periods, as you can see here. So yeah, really easy. All we did was have to flatten the table twice. So we flatten the city name, we flatten each city, and then we flatten the years lived within each city. And as you can see here, we start to sort of build a really nice relational database table. Super simple. These are just some of the queries. As I said, if we start adding new city names, new years lived, with less, I guess, or single values or double values, Snowflake can adjust accordingly. As mentioned before, that variant file format is really useful and will prevent errors. It sort of really, I guess, can pivot accordingly depending on changes in the structure of the JSON file or any semi-structured data. As I said, it can deal with XML, Parquet, Awk, and Abrel as well. So what I'll do now, we've had a look at how to perform, I guess, parsing on a JSON file within Snowflake. I will move to Alteryx to compare the pair, and we can have a look at what the JSON file shows within Alteryx. What I'll do, I'll leave the JSON here so we can see it in the corner, like so. Now this is Alteryx, the web UI, the designer software. As you can see, this is the interface, really clean to use. What Alteryx is, it is a drag and drop, I guess, rendition of data prep. There's also data science capabilities, machine learning, geospatial, visualization. As mentioned before, it is quite a one-size-fits-all tool. Very useful for a bunch of different data manipulations, preparation, and so. So what we'll do is we will run an input tool. Simply drag my file, which I believe is on my desktop. JSON webinar, yep. I've just taken this file in. I'll make it a UTF-8 because it's on Notepad. Run this file, and as you can see here, Alteryx has automatically removed a lot of the indentations, the speech marks, the arrays, and the objects, and put it in a table like so. Similarly to Snowflake, we get the children 0, 1, and 2, as well as cities lived in and years lived in. Now, if your JSON file doesn't format like this, for example, if we take the file, copy it, put it in a input and like so. Let's remove the second field. Delete that row. And if we have a text input, say your JSON renders and it leaves it in the JSON form, Alteryx actually has a tool called Jsonpass. Now, this is a tool I think that's been introduced recently. So if you don't see it on your Alteryx designer, you probably need to update. Again, it's a simple drag and drop to the input, and it will output the file how we did initially, the exact same. Really useful tool, this one, just to work on the fly, work really quickly. Now, what we can do within Alteryx, like we have in Snowflake, we can start to transform some of this data into a traditional relational tables. So what I'll do is I will run through some of the tools, provide a sort of simple example of how we can use Alteryx to, I guess, create some really useful tables which can be used to visualize or create a data model, etc. I'll start by bringing in a filter. The filter tool allows us just to provide a true or false metric. What I'm going to do within here, just wary of time, I'll build a children table, just so you can see how we can transform something as crazy as looking as this into a really easy to use traditional children's table. So what I'll do is I'll grab the filter. Again, this is probably not best practice, but I'll just take the left of the JSON name and make it 2. Characters of the JSON name need to be a CH. Again, there's obviously, I wouldn't suggest doing this if you had a huge table, as there could be other CH fields, like for example, church. But as I said, just wary of time, just to get the children values separated from the rest of the file here. We can already start to see we've got children 0, the first child, and the other child as well. So we can use our T here, which is our true functions, to use the, I guess, rest of the file. Yep. Okay. What I'll do now is I will pass the values here. I'll grab a regex. This is more of a complex, I guess, sort of tool. The regex tool allows us to separate our output into multiple columns. Ignore the code there, it's quite complex. So what this has been able to do, there's a bunch of different tools, but again, I'm sort of just trying to get this done nice and quickly to show you guys, just wary of time. But again, here, what we've done here is we've taken our JSON name and we've split it by the full stops here. So as you can see, the children field comes out as our number 1. The number of the child comes out as our second column, and the third is our final, I guess, category. So what we will do is we'll grab a select tool, which is a really useful tool. This is where we can select and sort of name. So our numbers, which was our second one, I will name as the group. Our third one, I will name as our headers. And our first one as our values. I think that was correct. Within the select tool, you can start to manipulate which order you want to see them, deselect and select. So I just have the headers, the values, and the group selected. If I run this, now I can start to see our name, gender, and age. For child 0 are these values. I've named them this particular way just to make the crosstab easier, which is what we'll be doing now. So the crosstab is a way to place the data from columns to rows. So you group by a specific value. So we want to group by each child. So child 0, 1, and 2, hence is why I named it the group column. We want to change the headers to the headers column, and we want our values to be the values column. Since they're all unique, we can choose any one of these. I'll just concatenate it, and I'll run the Crosstab. Now, as you can see here, we've started to build our child table like we have in Snowflake. I can grab another select tool here, as we no longer need our group. Simply remove the group and hit run. Now, in a few simple, easy building blocks, we've transformed a JSON file that looks like this into an age, gender, and a name children's table. Again, it depends what you want to do. You could use this to join to other tables, build a sort of data model. You might want to visualize something like this. It depends really what your goal is to, I guess, how you design your workflows. I'll do a similar thing with the cities fields. So just to show you again some of the ability of Alteryx to work really quickly, it's really good for business and data analysts. You don't need to know a lot of code. It's more of a drag and drop feature. So it gives people, I guess, the ability to jump in and start exploring the data really quickly. So that's a cool, I guess, part of Alteryx. Like I have here, I'll just do this a really quick way. Again, wouldn't say it's best practice, but it's a way to show you guys some of the different tools within Alteryx. So we want to look at the cities lived. As we can see, it starts from row 15 and goes all the way to the end. So we basically want to remove the first 14 rows. Now what we can do is grab the sample tool, and cool thing about Alteryx, you can connect multiple workflows to the same input. Depending on what avenue you want to explore, you might want to try different things out, restrict certain things. You can have a whole bunch of different outputs from this one file. Really good for, I guess, data exploration. Within the sample tool, there's a bunch of options. As we said, the cities table starts on row 15, so we want to skip the first 14 rows. If we run this and click on our output tab, as you can see, it has taken out the first 14 rows, and now we're only lived with our cities lived by values. What we're going to do, as I said before, you can sort of ignore this regex step. It is a little bit of a head scratcher to people that have never used it, but again, it's just a bit of a way to sort of skip some time and make it really nice and cool for us. It basically, again, it's the same function as the one up here. It just splits our JSON name by the full stop. So cities lived, the group, and then the final part. I've only used 3 different blocks, hence why there's another full stop in the third. That's not there. Like I have before, to clean it up and make it a little bit clearer, I'll add a select tool. Within the select tool, I like to name my columns nice and effectively. So our value, I think 2 was our group again. So our 0, 1, and 2. And I think 3 was our name. So I can remove JSON name and 1. Now, if I run this, let's have a look. So our values, our group, and our name. Now, as you can see here, we've got city name is London, and we've got years lived in at time 0, at time 1, the second, and the third. Now, if we performed a crosstab like we have here, we will get a whole bunch of different columns based on these values. I will run that for you now, just to show you what I mean. Nice and quickly, we'll group by the group, we will header by the name, and value by the value. We'll concatenate. And like so, you will get London and years lived in a bunch of different columns. Now, this might be how you want to run your show. Again, it depends on what you want to do with your data. If you want to insight analysis, visualization, build a data model. Just to show you something different here, I thought I would, I guess, take a different route and concatenate them. Just if we want to see it all in one column. Again, just highlighting some of the features of Alteryx. Just again, I will take the regex. I will do it as a parse. Again, this is just taking splitting by the full stop. So let's have a look what we get here. Oops. Field. That's the one. So here we're splitting our name up again. So we've got our values, our group, and our new name. Again, to make things nice and clear, remove the old name and rename this as the new name. Now, once we get all the values as the same for the years lived, it's kept the full stop in there and it's taken off the E. Ignore that. I'm not exactly sure why there. But as long as these are all the same, so the city names are all the same and the years lived all have the same header, what we will do now is run the crosstab and we can see the differences between the two. So again, grouping by group, headers by names, values by value. Now this is how we want to aggregate it if we want to see the first or last only. But I'm going to concatenate them, which means separate them by commas. And as you can see here, this is what we get as our output. Quite different to this, which splits it up by, I guess, the first time he lived in London, the second time, for example. Here we've looked at concatenation. Again, we can group by the aggregate by the first. So we might be interested in only the first time someone moved to a city. It depends what your business use case is. I just wanted to highlight some of the different ways Alteryx can deal with JSON files. As you can see, you can build different bridges. There's a whole bunch of different prep tools, join tools. As I said, really useful for business analysts and data analysts who aren't as technical. You can sort of perform your simple joins between different tables, like so. You might want to join this to this, etc. Really, really simple stuff. I guess what I'll do now is I will go back to the PowerPoint and we will have a look at combining the tools. Now, combining the tools, to start off with, I'll give sort of an overview of what we've done. So Snowflake is a cloud data warehousing solution and a modern one with its like very, very crazily modern scalability and pricing platform. Whereas Alteryx is more of a self-service analytics. As I said, it's sort of like a one-size-fits-all data prep, blending, automation, and even visualization to some extent. So they're very different worlds that both sit under the data umbrella. Warehousing and then data prep, obviously different purposes, I guess. But what we can do is we can start to join the two to take advantage of each other's, I guess, positives. So the first thing to note is obviously Alteryx's low/no code platform, which I've said multiple times. It's more easily accessible and taught to those with a non-technical background. Over 100 tools. You can start to, I guess, get new insights on your data once you've created the model with machine learning and data science, etc. And you can keep testing and building that workflow out, take multiple routes. As I said, it's really, really quite fluent with that ability. Snowflake is, as I said, more of a data warehousing solution with its awesome scalability and performance. So what you can do to join the two is combine Snowflake's near unlimited scalability and put it into Alteryx easy to use platform, and then obviously further that by using Alteryx's machine learning and data science capabilities. What I'll do is I'll go back to Alteryx now and show you the in database tools. Now, this is what we're going to use to connect to Snowflake. So what you need to do, you need to go download the ODBC driver. It takes about a minute. It's really, really simple. But within this tab here, we can use our in-database tools. Now, basically, this takes the positives of both worlds. Because of the extremely good performance of Snowflake and the scalability, as I mentioned before, we bring our data and we can perform those SQL functions that we did in Snowflake with our Alteryx buttons here. We can do this quite efficiently and easily. What I will do is I will connect to the database. You need to configure, I guess, your profile and connect to your Snowflake instance. I've already done this. Takes about a minute again. It's all just username and a password. And as you can see here, as soon as we bring our tool in for the in-database tools, we get our tables. Now I might just show you something else, I guess, to mix it up. Let's look at store sales. Simply run this, and we need a browse tool. So we can connect a browse tool like so, which just acts as our output anchor for the in-database tools. Once we've configured ourselves here, we can run it, and then straight away, this is what we would see in Snowflake if we just select start from this table. This, by the way, if we wanted to look in Snowflake, is just simply within our Snowflake sample data schema here. It's one of the tables in here. I just thought I'd use it as an example to show how easy it is to connect to Snowflake. You can use the regular tools, but you need to be, I guess, a little bit more wary on, again, your purpose, your goal. If you're just exploring, it could be useful, but we want to, I guess, push as much of that processing power back into Snowflake as possible, hence the in-database tools, because of Snowflake's awesome power. So I guess if you are going to use some of these regular tools, there's obviously a lot more to choose from. Do your research, because it's going to be really, really useful, I guess, to look at the positives and negatives of each approach. But within the in-database tools, there's still the select tool. We can still summarize, perform filters and joins. So really, I guess, all you would really need for this kind of, I guess, example. Just quickly, I'll run through again. It's nice and simple. Grab a filter. We might select a field, let's say price field here, net profit. Net profit, we might want to see the high earners, let's just say 5,000. Again, within the in-database tools, you need to run a browse tool, so we can look at one for the true anchor, and I'll grab one for the false anchor as well. Run that file, and we can grab all the net profit files that are above $5,000 and all of those that are below. Again, this might be useful if you're using a sample. You might want to take the top 1% of profit, and then see, okay, look at the regions from those. Look at the regions that they came from. They all came from Sydney, New South Wales. All of our profit seems to be coming from there. Whereas we might look at the bottom 1% of net profit and see that, okay, our bottom 1% seems to come from a particular store in Canberra. Why is that happening? Just things like that. As you can see, the false label here, all of our net profits are quite low. If we go to true, they'll all be above that 5,000 mark that we specified. So really easy to, I guess, investigate and explore some of your data. Again, there's a bunch of different things you can do. You can write your formulas, you can clean it up with select. I might want to take something like this and just remove a bunch of fields that I don't think I'll need, don't need this, and might just keep my net profit. And then maybe join that to a store table. And then all of a sudden I have my store, my net profit, and my date, something like that. And then you can take that to execs or managers, say, hey, I've noticed this, I'm going to visualize this, link this into Tableau. Alteryx has some reporting tools as well. Yeah, the possibilities really here are endless. And I guess I just wanted to highlight that end-to-end solution. When presented with JSON files that look like this, to the naked eye, if you're not familiar with them, this looks quite confronting. And this might be something that business analysts or data analysts often look at and go, I'm not technical. I can't even read this. It doesn't look like English to me. I'm just going to throw it away. And you could be wasting some insights within this kind of files. I guess within today's modern world, JSON and semi-structured data is a lot more popular than it used to be, particularly when you're looking at, I guess, social media interactions. I know a lot of Twitter files are in JSON. Mobile application data, a lot of that's in JSON as well. And to be able to use Alteryx's easy-to-use interface to convert something like this to a proper relational table or on Snowflake itself, with that variant file format, really adaptable and scalable, super simple stuff, as we mentioned. Obviously, some of the codes, it might take a little bit of time to get used to, but as I've said here, it's mainly just flattening the tables where you see fit, and then just taking your columns. Again, when you start to grow your data set, you'll start to see there are a bunch of different ways to do things. And this sort of wraps us up, I guess, as far as content goes. The next discussion is probably the schema-on-read versus schema-on-write discussion, which I guess without saying it, we've been discussing this whole time. So schema-on-write is our traditional database management, pretty much involving creating tables and creating relationships between them. So our typical joins, our primary keys, our foreign keys. Now, the downside of this is that you need to define the database schema to suit the data, but then also structure the data to define to fit in the schema. So it's kind of like a two-way street. Often you can't design your schema without seeing raw data, and then you can't, I guess, fit data into a schema unless it is appropriately structured. So this is where your data engineers sit in, and you can waste a lot of time and resources in this ETL stage, which is obviously what most businesses have to apply. It is just the way that things have been done. Where Snowflake comes in is the schema-on-read argument. Now, data structures aren't applied or initiated before the data is ingested. It's created during the process. So as I said, as the JSON files change between the three types of structures, Snowflake can adapt and react and pivot its schema accordingly to allow this unstructured data to come in without errors. So if you start getting, I guess, more and more nested arrays, if you worked in a schema-on-write environment, you might have to specify, okay, each child, each city lived in can only have a city name and a years lived in. But then if they add another field saying suburb lived in, then the whole thing will shoot you an error, and you need to grab your data engineer and rewrite some of that code to allow the new fields to fit in. Schema-on-read allows it to flow in automatically and not throw that error. So really, really useful for unstructured data. Again, there's no right or wrong. It depends totally on your use case. But typically it has to do with, I guess, what kind of data you're working with. I would say the schema-on-read process is faster, has the ability to scale up rapidly, and you can probably save some time and resources in that ETL stage, whereas the schema-on-write's probably slower and more resource intensive, but is the traditional way to do things, and can be, obviously, once the structure is written, you get that really fast, I guess, consumption of data. It's more the building blocks of schema-on-write that take some time. But we've sort of been, again, as I said, discussing this throughout. So I just wanted to wrap up by saying the schema-on-write, the sort of more advanced, I guess, new way to look at things when working with unstructured data, the schema-on-read. So what I'll do now is I will jump in the Q&A to see if there are any questions. Okay, what are the most typical challenges when parsing JSON in either tool? What should I pay attention to? That's a good question. I guess it has to do with the different structures of JSON. Again, if you're looking at particular tweets, you can start to get a whole lot of these nested arrays, nested objects, and you can start to get indents that sort of go on and on and on and on and on. I guess it's just sort of dealing with that sort of challenge is probably the toughest thing. But as I said, with Snowflake's variant column, it's very, very easy to deal with those kind of problems nowadays. I guess another thing is probably just to get started within it. As I said, I see a lot of business analysts and data analysts that aren't as technical, see JSON files or request, hey, I need the data for our chatbot. it comes in JSON format and they just go, oh, that's way out of my pay grade. I can't be bothered chasing it up. I'll throw that away. That can be part of the backlog. So I guess the biggest challenges are A, what kind of data you're using and how complex it can get. B, what you want to do with it. Do you want to build the traditional relational database? Do you want to put it in a format to visualize it, really setting out your steps before you start? And then C, just getting stuck into it, just so you don't miss out on some of those insights. Again, how do I get in best touch if I have further questions to this topic? Good question. Looks like Philip's answered that one with the Billigence email address. I guess that could be my cue to move on and wrap up here. Thanks everyone who attended today. Here is how you can get in touch with Billigence. This webinar will most likely be updated to YouTube with a whole bunch of other webinars on Alteryx, Tableau, Snowflake. There's a bunch of different ones on there too. The LinkedIn and the websites are also there, as well as my personal LinkedIn and email if anyone would like to reach out for any further questions. But again, hope you all had a good afternoon and learnt a thing or two. Thanks for being part of the session, and we hope to hear from you soon enough. Have a good night, guys. Thank you.